Hello again, everyone. Mr. Cruze here, working through yet another test review for Algebra 2. This time it's the Quarter 3 test, the big test, which should drop your lowest test score. Alright? So, big important thing here, it can boost your grade. So, here we go. Questions 1 and 2 ask us to simplify each rational expression, state any restrictions on the variable. Okay. So, simplify, well, let's factor things out. On the first one here, what multiplies to 25 and adds to 10? Well, that would be 5 and 5. So this will be x plus 5 times x plus 5. And in the denominator, what multiplies to 20 and adds to 9? Well, that would be 4 and 5. Okay. Well, before I can go ahead and cancel anything, I need to make sure what numbers x cannot be. That would be negative 4 from this one, and negative 5 from this one. Hopefully some of this comes back to you as we go. Since they are the same, the x plus 5's cancel, so I'm just left with x plus 5 over x plus 4, as long as x is not negative 4 or negative 5. Okay? Number 2, same thing, only now we're multiplying, so let's factor everything. Multiplies to negative 24 and adds to negative 2, that would be negative 6 and positive 4. What multiplies to 12 and adds to 7, that would be positive 3 and positive 4. X squared minus 1 factors into x minus 1, x plus 1, and x minus 6 is in the denominator. So let's check our denominators. What can x not be? That would be negative 3, negative 4, and 6. Let's cancel everything in the top. That's the same in the bottom. So x plus 4's go away. The x minus 6's go away. So we are left with x minus 1 over x plus 1 over x plus 3. Now, sometimes they might FOIL that back together to get x squared minus 1. Just be on the lookout for that. Alright? Number three, simplify the sum or difference, stating restrictions on the variable. Okay. Well, to do this, to add fractions, you have to have common denominators. So, let's factor the bottom. X plus 2 and x minus 2. Plus 6 over x plus 2. Now, look at the denominators. Currently, they have an x plus 2 in common. I need to multiply this second one by x minus 2, though, to make things right. So this becomes 3x over the denominator. Plus, let's go ahead and distribute the 6 to both places. That'll be 6x minus 12 over our common denominator. And now you may feel free to go ahead and add the numerators. So you get 9x minus 12 over x plus 2, x minus 2. Quick scan, make sure nothing reduces. You could arguably factor out a 3 and make that 3x minus 4, but I noticed that nothing is going to cancel if I do that, so that's actually not a good use of time. It also asks for any restrictions, so x can't be negative 2 or 2. Those are your restrictions, so there you go. Number 4, solving each equation. Check each solution. Basically, what check each solution means make sure your answer doesn't make the denominator 0. Okay? We don't want to divide by 0. That's bad. So 3 over 2x minus 5 over 3x equals 2 over 1. Okay? If I can make the denominators all the same, then I can just look at the numerators and we are good to go. So let's multiply this one by 3. Let's multiply this one by 2. And let's multiply this one by what the denominator will be, which is 6x. Okay? Anyway, it transforms into 9 over 6x minus 10 over 6x, and that equals 12x over 6x. Here's a really cool thing. Since all three denominators are the same, I can really just kind of ignore the denominators. And then it's a simple algebra problem. 9 minus 10 equals 12x. Negative 1 equals 12x, which gives you x equals negative 1/12. Quick check to make sure that won't make our denominator 0. Well, the only thing that will make that 0 is 0 itself, so we are good. Okay. This one's really simple. Just cross multiply. 1 times x minus 4 equals 5x. So, of course, x minus 4 equals 5x. Subtract x. Negative 4 equals positive 4x. Excuse me. and that means x equals -1. Again, quick scan to make sure. So that would be 0. The only number that would make that 0 is 0. This one would be 4, and that's not the answer we got, so we're good. Direct variation. Y varies directly with x. Well, that means y equals kx, where k is your constant of variation. Okay? It's always constant. It's never going to change. All right? So, when y equals 165, x is -5. Okay? So, what's k? Well, a quick dividing, and I believe k comes out to be -33. So, plug that back in. Y equals -33x. Now, let's take a look. What's x when y is -10? Well, let's figure it out. Quick division. Nothing cancels except for the -1s. So, x equals +10 over 33. Ah! Fractions. Fractions are okay, guys. They're not that big of a deal. Okay? Simplifying radical expressions, okay? You will have a table tomorrow of your perfect squares, perfect cubes, and perfect fourths. So just be looking for those. But anyway, we're looking for the largest perfect cube on our list that breaks, or that divides into -250. Since it's negative, you always want to pull the negative over to our perfect cube radical. 250, well, the largest on my list is 125, and that goes in twice. X to the 6, you're looking for the largest perfect cube. Well, the perfect cubes are x to the 3rd, x to the 6th, x to the 9th. What's the largest one that goes in? X to the 6th, with no x's left over. You used all 6 of them. What about y to the 5th? Well, same thing. Y to the 3rd, y to the 6th, y to the 9th. You can keep going forever. 3 is the largest, with 2 left over, because they have to get back to 5. All right. So everything in our left radical is everything that we can take the cubed root of. Everything in our right radical is just all the junk that's left over. Okay? Cubed root of -125 is, of course, -5. Cubed root of x to the 6th is x squared. You just take 6 divided by 3. Same with the y. Y to the 3 over 3, which is 1. And you really don't have to write first power. Okay? And the cubed root of 2y squared. Now, do I need absolute value? And the answer is no. You only need absolute value when your index is even and it comes out to be an odd power. So there's your answer. All right, cubed root of 6 times cubed root of 16. Since they have the same index, you can multiply the radicands, the numbers under the radicals. So this will equal the cubed root of 96. And then you look for the largest perfect cube that goes into 96. And I believe that is 8. And it goes in 12 times. Okay. Cubed root of 8 is, of course, 2. And then the cubed root of 12. There is no other perfect cube that goes into 12. So that is it.